Hi everyone, and welcome to this Keptn User Group. Today we are going to talk about how to automate and evaluate load testing with Locust and of course Keptn. It's my pleasure also to have today here Lars Holmberg. Hi Lars.
Hi.
And he will give us an introduction to Locust, what it is, how you can use it, what it can do. And then I will show you how to actually use Locust inside Keptn, how to use the Locust integration we've built in Keptn, and how you can automate and evaluate your load testing. So the agenda for today is Lars will give us this introduction. What is Locust? Maybe you've heard of Locust before, maybe you have not heard of Locust. So we will get an introduction to Locust. And then we will see how to use Locust and service level objective-based quality gates in Keptn, how you can even build, let's say, a self-service platform for developers to trigger quality evaluations with Locust and Keptn. We will have a demo prepared, and yeah, actually at the end, you're very much invited to give it a try yourself. So with this, I'm already handing over to Lars to show us what is Locust and what it can do for you. So this is actually part for later on, and I stop sharing. Here we go. Cool.
All right, so I hope you can all see my screen. My name is Lars Holmberg, and I've been a performance tester for about 15 years. I've worked with JMeter and LoadRunner, and then some more JMeter, and lots with Locust in the last 5 years or so. I have been a contributor to Locust for a long time, and I am currently the main maintainer of Locust. So I'm the one doing most of the code reviews and stuff like that. And yeah, I live in Stockholm, and I work as an independent contractor. I have worked with Locust at Klarna and at the Swedish state-owned gaming company called Svenska Spel, where I am right now. My company is called Redshirt Consulting, so I give you Redshirt today. But without further ado, let's start looking at Locust. Locust was named after the swarming grasshopper, the thing that basically attacks and eats everything in big swarms. And it was created in 2011, so it's been around for quite a while. It was originally made by a guy called Heyman, another Swede, and he made it for use at the gaming studio called DICE, makers of Battlefield, if you've heard of that. But right now it's used by lots of other places as well. So it's used by Klarna, it's used by Zalando, Delivery Hero, Svenska Spel. Also seen it mentioned by Microsoft, talking about like how to run Locust on Azure and stuff like that. So it's all over the place. But why should we use Locust? I would say the main reason for using Locust is that you get to write user scenarios in just regular plain Python code. You can use any programming constructs. You don't have to learn any weird GUI to do stuff in. And you can maintain your tests as you would any other source code in Git. You can diff if you run into some issues, stuff like that. It's really useful. It's distributed and scalable. It might not be the fastest load testing tool if you're counting like requests per second, but it is very low overhead for the number of users, and you can scale it infinitely, really. You can simulate hundreds of thousands of users. So it's quite scalable. You can use it to test any protocol, really. Oh, sorry. There are implementations for the protocols that I mentioned here, but if you want to test some special service which is not HTTP, you can definitely add that with very low effort, and you can easily modify behaviors and add new things into Locust using hooks. Like if you want to send your data to a certain database, or if you want to, I don't know, do some setup or tear down before or after your tests, there are hooks available for that. All right, let me show you the most basic Locust file. So let me make that a little bit bigger. So like I said, you can do anything in a Locust file that you can in Python. So you can import any modules you like and just run it. Here we import something called an HTTP user, which is, if you use LoadRunner, it's something similar to virtual users, or in JMeter, thread groups. So a user defines a behavior which you can then run in Locust. So our user, called demo user, has a task, and tasks are something that users can run. It's called hello world, and what it does is that it uses the client, which is an HTTP session. It's built on Python requests framework, so it's like the normal Python HTTP client, and we use it to call to endpoints. Before I show you this running, I'll just do another quick example, another task with higher weight. So this 3 here means that this task will be executed 3 times as much as this one. And it also does a small loop here, just to show you how you can use regular programming constructs in the Locust file. Also, there's an onStart method, which will be called before this user does any tasks. So that if you want to log in, or if you want to get some, I don't know, get some data for that specific user, you can do that. I think I can show you just running it once in the debugger, because that's something you can do as well. So you can see, like, there's some, just ignore this text for now. But yeah, so you can, if you have like an issue in your script, or if while you're developing your script, you can definitely use the debugger as you would any other Python script or application. So you can see what's going on, and like this user doesn't have a lot of data, but if you put, like, I don't know, user ID as an instance variable for your user, you would like be able to investigate that here in the debugger. But let's look at how you actually run Locust, like in a normal case. So you do it something like this. You say, oh, which Locust file do I want to run? And where do I want to direct my load?
Can you zoom in here also a little bit?
Oh yeah, sure. Actually, I'm not gonna.
Yeah, it's
show
really better. Thank you.
Yeah. Okay. So let's open the web interface. And let's simulate 100 users, and let's spawn them quite slowly so we can see what happens. So as I showed you, like the test that's being run here, it just does a few things. It just does 4 different types of requests. It does login, and then it does hello and world and item. And I have a small service that I'm calling, which is a fake service, and I've introduced a performance bug into it so that this one will actually be quite slow if you increase the load. So let's see how it goes. So as I mentioned, this is the web UI for Locust. You can use it, or you can just skip it and do everything from command line. This web UI is good for like analysis, but in reality, I don't actually use it that much because we have a different backend. We send all our logs into a timescale database, then use Grafana to visualize everything instead of looking at this web GUI. But as you can see here, we have all the requests listed, and you can see that this one is actually quite slow. And it's even getting worse as we go along. So let's have a look at the charts, just to give us some more info. Here you can see the ramp up. Oh, sorry, I can just move that one. So you can see the number of requests, which is the main graph here. The number of requests are increasing as we ramp up the load. You see here now we're at 73 users. And this is the total request rate. But you can also see that the response times are increasing as well. So this is a bad result. This system does not perform very well. And here you can see the ramp up happening. Okay, yeah, and now it's finished ramping up. It's at 100 users. And yeah, there are other tabs here as well, but they're mostly for when you get errors, which we don't have right now. What we should see after a while here is that this should start to level off because the load is no longer increasing, but it's just stable. Okay. Any questions so far? I know I'm sort of rushing, but I really want to.
Sorry. There is actually a question coming in via the Q&A. What's your best practice on data-driven testing? Meaning, how would I pull data that I need for my test? Is there anything in Locust that helps me query my test data?
So there are several ways to handle test data in Locust. The most basic one is just to use some sort of CSV file of which you can read directly. I can show you. This was something I was going to mention anyway. Locust plugins is sort of some additions to Locust that we have built at Svenska Spel. And one of those things is it contains 2 readers. And they allow you to read test data from a CSV file or from MongoDB. We actually use this one more, but this is the easiest one to get started with. So if you just have a CSV file, let's say with social security numbers, you would just instantiate it and then just read lines from that. Does that answer the question?
I think so. If there's any follow-up question, please just let us know in the chat or in the Q&A. And if there are more questions on other topics, also please use the chat or Q&A function. We will forward it to Lars.
Cool. Yeah, and here's another example of how you would use the Mongo reader, but it's basically the same. Just read your data as you would normally using Python or one of these pre-made ones that will help you get started. Cool. Just let me know if there are more questions because I can't really see that right now. But let's close the web GUI for now and look at how you would run it from command line. Because if you want to do continuous integration or running this automatically, there won't be a person looking at the GUI. So we need to run it from command line. So there's a reasonably new feature in Locust. It's been around for maybe a year or something, that you can configure Locust not just by command line parameters, but by using a configuration file. You can also do it actually using environment variables. But let's look at the configuration file. So this configuration file will point Locust to the same host that I mentioned on command line earlier. It will select this test plan, this Locust file. It will run it in headless, so no web GUI, and it will just launch immediately and ramp up to 100 users and add 2 more users per second until it reaches this number. And also add a runtime limit. So after 30 seconds, it will just stop. Actually, let me make that 60 seconds. So now, if I just run Locust like this, it will run using those settings and output this data to command line instead of the web GUI. So let's just leave it running. You can see the same behavior here where this item is reasonably fast in the beginning before we start ramping up. But as we add more and more users, it just starts to break down. So yeah.
You can already see it's getting slower and slower. And what we can also see here is like the number of failed requests. It would be directly available also via the via Locust. But it seems that this is not the problem here.
Yeah, so as we finish here, we get sort of one final report, and we also get a detailed report of the response time percentiles. So as you can see, the response times for everything except for this one, where I've actually sort of, oh, what's the word? Intentionally made it slow. Everything else is just fine. All right. Yeah, just quickly, I can show you the way it works when you send the data to Timescale database. We have Grafana that shows a view. This is just a screenshot because I didn't have a good test run in place. But here you can see like how to visualize a test run, and this is what you can do after the test was run. So it's quite convenient reporting it to something. I think I mean there are lots of options here. You can rely on the system monitoring that you have in place if you have Prometheus or something. That's also quite useful. The good thing here is like you get some aggregated and specific data on like what failed, if something failed. Yeah, cool.
I think there is a question coming in related to this. So I will take the last question first, which is the data storage also pluggable? Could I send the data to another database as well?
Yes, and this is exactly what we do here. So we're using something called Timescale Listener, which sends the data into Timescale. Where is it? There. So yeah, basically that uses, I can show you just the core of this. Actually, let me just show you the simplest listener there is, which is the print listener, which just hooks into the request event in Locust. You can see where that is done. That's done here. So basically, you just say, oh, whenever there is a request, trigger this function. And then it does a little bit of magic, but mostly just prints the failing request. So that will give you to standard out what went wrong, basically. But the more real listener here, which is Timescale, works in a similar fashion. It just writes data to a Timescale database. But as I was what I wanted to show with the print listener was basically just it's very easy to plug in some sort of other database. There's also, I believe there are Prometheus endpoints, but I am not sure. I haven't used those myself, so I can't really say how good they are. But then Locust itself would expose a Prometheus endpoint. If that's the word, even maybe it's called something else. I'm not an expert on Prometheus. Anything else? There was another question.
Yeah, we can take it right now. The question: is there some kind of concept of user profiles simulating different connection speed, different browser types, even maybe some kind of user behavior? Is this possible?
Yeah. So there are. So if you're talking about like simulating different types of users, what you do is just you define another class called whatever. Let's call him slow user, and then a single task that just, well, he does hello world, but then he sleeps for 5 seconds. So if you were to run this Locust file now, you would get 50% slow users and 50% demo users. But there's not a built-in way to simulate slow network connections or anything like that. Mm-hmm. You can do that using something like, yeah, you would have to use like some Linux tool, firewall, to simulate that. What you can do is if you use Locust to run full browsers, which is sort of a rare scenario because it doesn't really scale very well. But if you do that, then you can instruct Chrome to do things slowly. Let me show you an example of that. So where is it? Oh yeah, here. So if you run WebDriver and run a full browser, you can use the built-in network emulation there. But this is not really, like I said, it's not scalable. You can run, I would say, at most some 50 clients per core. so it's yeah, and it's not very, because Selenium is not very stable under load. It's not very useful. I've only used it a couple of times, and then maybe as sort of something to run next to the load generation to do some particular measurements or something. This is also part of Locust Bytes, this WebDriver client. So that's where you find it. Okay.
Cool. Cool. Awesome. Yeah, I think at the moment there are no more questions.
All right. Do you want to continue?
Yeah, sure.
Mm-hmm. If there are any more questions later, I'm happy to answer. Also, if you have questions later, just come to the Locust.io Slack, or we actually monitor or I actually monitor the Stack Overflow. So if you post a question on Stack Overflow, then probably you'll get an answer there as well. Cool.
Cool. Thanks so much for all this demo already, and I will be continuing here. So, and I will be more diving into how you can now use Locust with Keptn in combination with Keptn. And I'm not the expert on Locust, but it was actually quite easy to use. And I know we have some of the contributors to the Locust integration also on this call today or in this Keptn user group. So everyone feel free to also ask the questions to Lars if what are the best practices to improve this integration or how we can extend it. So what we've built with the Keptn team and the Keptn contributors is a Locust integration that you can use together with Keptn, and it will listen for test trigger events. If you are familiar with Keptn, you already know Keptn will orchestrate all your tools, and each time there is a triggered event, you can kind of react to these kind of events. For Locust, it makes a lot of sense to listen for test trigger events, and Locust will then start its action. So to install it, it's basically a one-line installation for the Locust service, and the Locust service will come with the Locust binary already included. So that the part that we've already seen, where Lars was showing us to start a Locust test with Locust and then -f a file name, or just Locust with the configuration file. This is actually part of this whole integration. So the only thing that needs to be done is to install the Locust service, which is the integration for Locust for Keptn, and then adding your Locust tests that you already have, you add them to Keptn. How to do this? It's the same as you would always do it, also with some other testing files that you have done maybe in the past with JMeter. You just use the Keptn CLI and do a Keptn add resource. And in this example, the resource is locust file.py. I think that's kind of the default name for a Locust file, but it can be any file name. Of course, you will also add which project, which service. I just made it a little bit abbreviated here and made it a little bit shorter. So now you have the Locust integration, you have your Locust tests added, and you can then trigger a delivery workflow or a delivery sequence in Keptn when the Keptn starts the delivery, starts the tests, does the evaluation, and can promote the artifact or roll it back. So with these kind of 3 steps, you are all set and you can make use of Locust already. So what you get with Keptn, in addition that to the Locust results that we have already seen in the demo from Lars, is you get the full power of the Keptn quality gate. So it's you can make use, of course, of the response time, the error rate, the throughput, all these kind of metrics that you might also see as an outcome of Locust. But I think what's also very important is that you can compare automatically. Or actually Keptn will compare automatically the outcome of one test run to a previous test run or to multiple previous test runs. And this is where the Keptn quality gates come into play. So if you define your SLOs, then Keptn, after a Locust run, Keptn will use data from Prometheus or Dynatrace or other sources to do the quality gate evaluation and compare it to previous runs or compare it to a fixed thresholds. So both is possible. And it's basically the step that you would do after you execute the load test with Locust. What's also possible is to provide really a self-service platform for developers. I will also show this in the demo, but instead of doing the full continuous delivery from, let's say, development and to hardening and production, you could also use just one sequence in Keptn and only use this sequence for a performance test, for kind of a self-service performance test to start a deployment with your new version of your, say, shopping cart, or I don't know which service Lars was using that had already this performance degradation, but just use this version and trigger this performance test sequence. And Keptn will make sure to do a deployment to trigger the tests with a predefined test strategy, or the test strategy you can define here in the sequence, and to also do the evaluation. So with this, and there is no promotion to the next stage, there is no rollback defined. So with this, you can always make sure to use Locust plus Keptn for evaluating the performance of the service. You don't have to set up anything. You can just use this as part of a stage that you might already have, and you introduce a new sequence in this stage, and then you can have this testing and evaluation. And one thing that has also been added just recently from the Keptn community or by the Keptn community is the support for Locust configurations. So the default way to execute a Locust test also in Keptn is if there's just one file called locust file.py, then Keptn will pick up this file and will execute it as part of the testing task. If there's also a locust.conf file, Keptn can pick this conf file up and can make use of this file. And also related to other specification files or configuration files that you might already be familiar with in Keptn is a .conf.yaml file where you can easily map a test strategy to a file that should be executed. So I just put here a very simple locust.conf.yaml file where it says if it's the test strategy, if the test strategy is functional, the script is to be executed is a basic.py file, and there's also configuration that should be used. But the configuration is not mandatory. So for example, in this case, a functional light test strategy could mean you would only just use this file, or on the other hand, if you don't have the script as part of the configuration file here, you saw this also in the demo from Lars. If the script is also part of the locust.conf, then this is also possible. So there's multiple ways how to configure which test file is actually executed. There are instructions in the GitHub repository of the Locust service, and you will find your way how to write this locust.conf YAML file in which tests are actually executed. So with this, let me show you a little bit of a demo how to run this and how to use it. So yeah, this is the Locust service. It's on Keptn Sandbox /Locust service, and here you can already you have all the instructions how to install it, how to use it, how to do the configuration part. So I use this in the latest version, but actually I made a small change that I will push also soon to the Git repository, so you can also make use of it. What I already did is a couple of different runs in preparation for today. So I did a couple of deliveries of my service, and I also did a couple of just performance tests, the kind of self-service. But let us start maybe with the delivery. So I will trigger, as you might already be familiar with, I will trigger a new Keptn delivery sequence, and I start with a Keptn trigger delivery for my sock shop project and for my shopping cart service. I will just use this image name here. It's the cards from the Keptn examples, and in the version 12.1. So this is the version I'm going to use in my demo, and this event is now sent to Keptn. Keptn will pick it up. Let me just reload. I can open for quite a while. Keptn will now pick up this event and will start the delivery sequence. So right now the deployment is going on. Keptn will make sure to deploy this by the Helm service, and then afterwards we will see the tests that are going to be executed. So let us have a look which tests are going to be executed and which tests I have already added and where they are stored in the Keptn Git repository. So we do have our Keptn Locust. Let me maybe start at the very beginning. I do have here my Git repository with all the information that Keptn needs. I have my shipyard file as a description for my whole project, and I have 3 different branches: dev, staging, and production. And let's have a look at what's happening in the dev branch. So I do have my shopping cart here, and I have also my Locust file here, or my Locust folder with a basic.py. So basically, in my I've just used the conf YAML from the demo, and what will be executed is my basic.py. And the basic.py is not doing a lot of things. It's basically only checking on or just sending a request on some endpoints, the root and the help endpoint. So it's doing a couple of GET requests. What we can see here in Keptn is also that the Locust service started, and this is just one very small improvement I made. Once it fetches the file that is going to be executed, it's also printing the file name here and where which service is going to be tested. So first it will indicate Locust service is starting, and once it's figured out which file to use, in this case it's the functional test strategy, so it was mapped to the basic.py, it also sends an update here. So this test will run now for about 1 or 2 minutes. Once the test is finished and the test is successful, then this will be also indicated here in the bridge, and Keptn can move on to the evaluation. So in this case, yes, the tests are finished. Keptn is already starting the evaluation. So in this case, there is not a lot of things going on in the evaluation, because the basic check is actually checking if the service is available, if I get a positive response from Locust. If not, it would be stopped here. And since we got the positive response from Locust, we can move it on to the next stage. So it's now being deployed in staging, and there are a couple of more tests running. We can also have a look which tests are running in staging by just switching into the staging branch here. So I'm just switching here into staging, and I can see here I don't have a lot of configuration. So I take the default settings of Locust. And since the Locust file.py is the default way how to name the test file in Locust, if this file is available, Keptn will just pick up this file. So in this case, I have, again, a couple of GET requests against my microservice, and I have also one POST request to add items in the shopping cart, and with the other requests, the items are again fetched. So there will be, again, a couple of minutes of those testing going on, with either posting items into the shopping cart or querying the items from the shopping cart. As we saw in the demo from Lars, we could also have a wait on these tasks to maybe add more items in the shopping cart, or with higher probability adding items in the shopping cart than maybe doing the health check. But this can be improved. So the main part of this file is actually, if you don't need any configuration file, then it's the only way, or the only thing you would need to do is to have a file that's called locustfile.py and add it to the Git repository of Keptn, and Keptn will pick it up. So we might already see tests are going on. It might take maybe another minute or two for the tests to finish, but in this case, we will also see an evaluation, and we have a quality gate based on service level objectives. The data here is coming from Prometheus. So at the moment, we are not using the data that is coming directly from Locust. So this is something that has to be improved within Keptn itself, to also make use of the data that Locust itself is providing. But we are using the data that is stored in Prometheus. So our microservice, the shopping cart here, is monitored by Prometheus. All the data is stored in Prometheus, and in the Keptn quality gate, Keptn reaches out to Prometheus, fetches the data, and does the quality gate evaluation based on SLOs. So we will see this quality gate evaluation just in a minute. In the meantime, we can have a look at our quality gate itself. So our quality gate is, as you know, described in the SLO file. And I've just added here a couple of different objectives, like checking for the response time at 95th percentile, but also the 90th percentile, for the 50th percentile, the error rate, the throughput, and also one very specific response time that is only for adding of the items. Since this might be a crucial transaction for my shopping cart, I only want to have this. And the queries, how to query all this data, is actually defined in the SLI file, as you also might know, which is also stored here. And we can, maybe in the meantime, we can have a look in the Prometheus folder. We have the SLI file, and all the different queries are defined here. You might see there is no indicator for the error rate or for the throughput, because this is the default way, the built-in way that we're going to use, and this comes with the Prometheus SLI service of Keptn anyway. So let us go back to Keptn. we see evaluation is already finished, and we can have a look at what is actually the outcome. Having a look here at this evaluation, we can see a list, a breakdown of all of our SLIs that have been evaluated, and we can see the actual value and the criteria needed to pass. What we can see here is that it's also, for example, here we are not satisfying the response time for the 95th percentile. It's actually satisfying a criteria. It's below the 600 milliseconds we need it to be. It's very fast, so this wouldn't be a problem. But we are also comparing it to a previous run that has been passed, a previous successful run, and it's slower than an increase of 10%. So this is something that Keptn can bring also to the table, instead of having only the evaluation of Locust, but we can also compare it to previous runs and then have a look. Okay, it's actually slower than an increase of 10% or 25%, or however you wanted to build, but compare it to other runs, and also have a combination between relative and fixed thresholds. So nevertheless, we scored enough points for it to be able to pass on to the next stage. So we needed at least 75 points for to get a warning, and the warning in Keptn means it's allowed to move on to the next stage. And we received this score since there was no errors, throughput was fine, and so the response time for the others indicated a passing result. So while this is now deployed in production and tested in production, let us have a look in how we can build kind of this self-service platform. And I see there are more questions coming in, but let me just start this. So let us have a look on how to trigger this, or maybe first have a look on how I built it here. I was already kind of saying this on the slides, but here in my shipyard file, I have dev, staging, and production at the end. But in staging, I also defined a task sequence for a performance test. And I want to use all the configuration of staging, but I don't want to move it on to promote it to production or need it to go through the dev environment with all the testing. I just want to have this staging configuration for my performance test, let's say. So I defined the deployment, a test, and an evaluation with some properties, and I can trigger this task sequence by just sending a cloud event to Keptn, and it will trigger exactly those 3 tasks. I've already prepared the cloud event here. It's triggering my performance test in staging. It will use a specific version of my shopping cart, and I have all the information I need. So let me now send this to Keptn, and I think I have it somewhere here. So I'm sending this cloud event to Keptn. Keptn will, of course, pick it up and start this exact performance test sequence with a deployment, a test, and the evaluation. So let us have a look here. Let me just, I don't even have to reload, so we can see performance test is started. It will start the deployment directly in staging and then execute the tests and do the evaluation. We can also give it a try with a couple of different versions to see which are the slow versions, which are the fast versions, or we could also take a look at some previous test runs I did earlier today. But while this is running, let me just find the Q&A window, and we can also answer some questions here. There is one question, a very good question. Is the report of the Locust test execution available in the Keptn's bridge? That's a very good question. So if we take a look here, maybe I have a look at this one. No, not even here. But I had some previous runs where the test execution was failing. If the test execution is failing, you will get the full basically it's not the stack trace, but the full output of Locust why the test was failing, you would get it directly into the Keptn's bridge. For successful runs, we right now do not include the full output, but you could also include it. What I did just in a kind of intermediate version is to also include what is the test strategy, what is the file that is now actually executed, what is the URL where Keptn is sending the traffic to, where Locust is sending the traffic to. So I just included this here. This can be improved, and we are also open here for suggestions from the community. So if you want to join us here in improving the Locust service, feel free to reach out or open an issue or pull request on the GitHub repository. So let me have a look if there are more questions coming in. I think there's more. So are there any plans to attach more than one file to the Keptn Locust run? I'm not sure if I understand correctly. Maybe that means if test runs can be that there can be one test run after the other, and this is for sure possible. The only thing you need to do is you just need to define, or you can define more test tasks. You can even name them differently and have different tasks in your Keptn shipyard, and then Locust can also react on this and start tests there. So that is for sure also possible to run multiple tests and not only one test. So not sure if more questions are coming in, but while we were waiting, we can see in this case delivery or a performance test sequence finished with a specific version of my shopping cart, where it did a deployment, a test, and an evaluation. In this case, the evaluation was completely successful, so it was very fast. Also, the adding of the items was faster than the previous run. So in this case, you can provide your developers a kind of a self-service platform where they can just execute performance test runs where Locust tests are triggered, and they would just use the Locust files that they already have and have them executed by Keptn. And then they also get the SLO-based quality data evaluation. So let me just, if there are any more questions, I'm happy to answer them, but just let me go back to the slides for just a second to kind of wrap it up here and then open up for more questions and answers. So if you want to give it a try, go to locust.io to learn everything about Locust, or just watch the video again where Lars was introducing Locust and showing us how to write tests. If you want to use the Locust service, it's available on Keptn Sandbox on GitHub via Locust service, and you will find the full installation instructions there and also configuration options. If you just want to learn a little bit more about Keptn, how to use Keptn, you can go to tutorials.keptn.sh. Right now there is no dedicated Locust tutorial on Keptn.sh. If there's any demand, we are happy also to add a dedicated Locust tutorial there. But you can also just replace your JMeter files that you had with the Locust files. So there is no need to rewrite the whole shipyard. You would just remove the JMeter service and use a Locust service and add Locust tests. So this is in this way you can already experience this. If you have any questions around Locust, then please join the Slack channel of Locust. If you have any questions around the integration, join the Slack of Keptn, and we're also happy to help you there. So with this, give it a try yourself, either via the Locust binary to get started with writing tests. And once you have written your tests, you have finalized this part, give it a try and use the Locust service in Keptn. So I'm opening up for more Q&A. I'm not sure if I answered the question from earlier. If I answered it correctly, please let me know in the chat or in the Q&A if this answered the question, or if you have any more questions to Lars, then I think we can also take them here. Actually, I would have a question on some kind of best practices, how to write or structure some Locust files. Is there any kind of guidance on the sizing of a Locust file, on how many tasks you should have in one Locust file when you want to start one set of tests and when you want to start another set of tests, like doing smoke testing or doing these kind of things in separate files or separate steps in your whole CD process? Do you have any, can you comment on this? Any best practices?
Sure. I mean, it's hard to name any best practices in general. I guess like when you're load testing, your first step is usually just warming up your system, running a single user or very few users just to make sure that caches are warm and system is active, and then start a proper load test a little while later. But in terms of how to structure the tests, I guess what we do at Svenska Spel, for instance, is that we have a base user class, which has wrapper methods for things like making REST calls. Like all the REST calls that we make may have like a certain header, or we want to treat the responses in a specific way. For instance, we check for a specific place in the response JSON for an error message. And if there is an error message, we automatically fail that particular request. We don't have to do that explicitly, check for that every time we make a call. So that's a useful thing where you just define a base user class, which you could put in a separate file and just import it. The one thing to remember there is that you need to mark it abstract, because if you don't, then Locust will feel like, oh, this is another user that I'm supposed to run, and then just make when you say you want to run 100 users, it might run 50 of your base class user, which you didn't really intend to. Yeah. I guess it's really hard to say, like, in general, best practices, but I hope that gives you some idea.
So maybe one thing to add, being a passionate Python developer myself, you don't have best practices in Locust because you have best practices in Python. And you cannot think of Locust of something like gemmeter where you create a GMX file. You really write Python code according to the best practices of Python, and then this just looks nice and it works. That's the best practice. Write the code in Python.
Yeah, I absolutely agree. The thing that we've standardized both in Locust since a couple of versions back, as well as at Svenska Spel and JMeter plugins and that stuff, is to use Pylint and Black for auto formatting, which makes it really it's very convenient. It's very easy to read other people's code. It's very easy to, well, I guess that applies for any Python project, really, but that works very well for us.
Cool. That was Christian who was commenting on Python, and big shout out on here to Christian and Dominic and Dieter, who also helped in developing the Locust integration. So I think this was really here a kind of community achievement, which is really great. And I was just the one presenting the outcome of the Locust integration, so it was not done by myself. But really cool to see this working.
And I have to say, it was quite simple to build the service itself using the service template and also reading up the Locust documentation. So those two just go hand in hand very nicely. So yeah, as you say, a huge team effort.
Yeah, and I think so. The Locust website is really a great resource to learn how to write Locust files. I kind of made my way through just by taking a look at a couple of examples to write or update a couple of files there. And yeah, I know that the Locust integration that we've built is already used in production. Not sure if anyone here on the call wants to comment on this also. If not, maybe we can then see this in one of the next Keptn user groups or developer meetings, how this service is already doing a lot of load testing in our continuous delivery. Yeah, are there any more questions from the community? Feel free also to raise the hand. I'm happy to unmute or allow you to unmute. Okay, if not, then I would like to thank you, Lars, again for joining us here in the Keptn user group. It was really great to learn what Locust is, how we can use it, how to write our files, how to reach out in case of questions. And thank you so much for joining. And yeah, thanks everyone also for joining. If there are any more questions, oh, is there any other question coming in? No. No. If there are any more questions, please join us in Slack. Don't hesitate to reach out, and we will have our next Keptn user group meeting on the 3rd Tuesday in June. In about 1 month's time, and we will hear a Keptn adoption story from a large company. So stay tuned. Okay, so we are already at the top of the hour. Thank you so much, Lars, and happy load testing, everyone, and see you all next time.
Bye.
Bye.